Today, we're going to do revision of arithmetic sequences. Let's see if you can still remember everything. An arithmetic sequence has a first constant difference, and the symbol is a small letter d. To calculate the first constant difference, we must have consecutive terms. For example, term 2 minus term 1. We can also say term 3 minus term 2, or term 11 minus term 10. All of them will give us the first constant difference. So when we have the difference between consecutive terms, their answers will be equal because they both give us the first constant difference. We also learned that A is the symbol for term 1. So instead of writing T1, we can also write A. Then we learned about this formula. Tn is equal to A plus D in brackets n minus 1. We use this formula to calculate the general formula, and we can also use this formula to calculate any term's value as well as the position of any term. Then this formula here is the general formula. When it is in this form, we know that the coefficient of n will be the first constant difference. Then we also learned that we can rewrite any term in terms of term 1. So for example, term 2 is equal to term 1 plus 1 constant difference. We can also say that term 3 is equal to term 1 plus 2 constant differences. And how do we test it? This 1 plus the amount of constant differences will give us this term's position, which is a 3. We can also rewrite any term in terms of another term. So, for example, term 7 is equal to term 2 plus 5 constant differences. And how do we test it? That 2 plus the amount, which is 5, gives us that 7. There we go. We also learned that we can get the sum of consecutive terms in an arithmetic series by using this formula here. So Sn is equal to n over 2, 2a plus d in brackets n minus 1, which are in bigger brackets. We can also use this formula for the sum of, as long as we have the first term or the term where we start to add up and the last term of our series. Then in our last lesson, we also learned that the sum of n terms minus the sum of n minus 1 terms is equal to term n. Okay, so this is all the different formula that you need to know, and if you remember all of these, you've got a complete toolbox to answer any question in an arithmetic series. So let's go and look at a more difficult example. The sum of the third and the 11th term of an arithmetic series is 150. Determine term 7. So I'm going to just rewrite these words in an easier way. So I'm going to write it as term 3 plus term 11 is equal to 150. Now with this information I cannot do much because I simply have two variables. So the only thing I can do is rewrite term 3 and term 11 in a different way. So I'll rewrite term 3 in terms of term 1, which is a plus 2 constant differences. Because remember, term 1 plus 2 constant differences gives us term 3. And term 11 can be rewritten as term 1 plus 10 constant differences. So this is all equal to 150 because that has the same meaning as this. So a plus a gives us 2a. 2d plus 10d is 12d, and it's equal to 150. Now to solve this equation, I'm going to make use of the common factor, so I'm going to take out a common 2. There we go. So what is left? A plus 6d, and it's equal to 150. Now I can take this 150 and divide it by this 2, and we end up with 75, and on the left side we have a plus 6d. Now if you look very carefully, this already is the answer we've been waiting for, because term 1 plus 6 constant differences is term 7. So term 7 is equal to 75. So I hope you learned something today, that if you remember all the relevant formula for an arithmetic series, you'll be able to answer most of the problems. See you next time.